Now we'll work with a vernier caliper. The way this works is that there is again an upper and lower scale. Here this is the centimeters 0, 1, 2, 3 on this axis here. And then on the upper we have inches, which we're going to neglect for our use. And then this is the lower scale down here, 0, 1, 2, 3 up to 9. And then 0 again is the minor scale. When it's shut, the vernier caliper isn't measuring anything, that is, then the zeros on the major and minor axes line up. So we can see that this 0 on the minor scale and this on the major scale, they line up quite well. And you'll notice nowhere else does that occur, that is the markings on the minor and major scale line up, except again at 0 here and there. We'll put our measurement object here between the teeth of the vernier scale and we'll close it. When we're measuring something, there's a flat side here and we'll want to put our device in that and then close it with a little bit of pressure. And then with that value, we're going to see what the measurement is. On the major scale, it's the question of where does the 0 on the minor scale line up with the major scale. So here we have a 0 on the minor scale, which is a little past this hash mark here. So that's 5, 6, 7. It's a little more than 0.7 centimeters. The question is, how much more than 0.7 centimeters is it? Since the 0 here doesn't line up with the major scale exactly, we need to find where on the minor scale it does. So there's no match here until we reach, say, the 6 value. So on the minor scale, the 6 mark lines up pretty well. You could even say the 7 mark lines up better. So we'll take this 7 as our minor scale measurement. Now the question is, how do we combine this 0.7 centimeter measurement on the major scale with the 7 mark on the minor scale? The answer to that is over on the far side of our caliper. There's a little marking that says 0.05 millimeters. This tells us the smallest unit of measurement for the caliper. So now when we look back, this 0 on the minor scale is somewhere between 0.7 and 0.8 on the major scale. So this gives us some confidence that our measure is correct. Now that we know the smallest unit of measure on the minor scale is 0.05 millimeters, that tells us what this 7 means. Each of these small marks from here to here is 0.05 millimeters, and so since this is 7, and then there are 2 marks per increment, there are actually 14 of these small measurements. The way we'll combine these sets of measurements, the 0.05 millimeters on the minor scale as the smallest measurement with the major scale of 0.7 centimeters, is we'll take the major plus the number of minor increments, in this case 14, and then multiply that number times the smallest measure. So what we get back after we convert to the correct units of centimeters, in this case, is 0.77 centimeters with an accuracy of plus or minus 0.005 centimeters. As a check, this makes sense because the value should be between 0.7 centimeters and 0.8 centimeters. And if we look back at our original measurement, we see that our 0 mark on the minor scale is close to the 0.8, so 0.77 centimeters makes sense. Now, as an example of what happens if our scale is slightly different, if we're using a different measure and we come up upon the case where the 0 on the minor scale lines up with an increment on the major scale. For instance, now I see that the 0 on the minor scale lines up very well with 1.7 on the major scale. What that does for our calculation is we still have a major scale of 1.7 centimeters, but now our minor measurement is 0 increments. And we multiply that times our smallest measure of 0.05 millimeters, and what we get back is a more precise measure of 1.70 plus or minus 0.005 centimeters.